All right, let's see how you did on your type 1 and type 2 errors assignment. So here on this first one, you're talking about measuring the brake width or the amount of thickness that's left on the brake pads, okay? Definitely something we want to monitor. And so the null hypothesis is that the average thickness of the brakes are 4 millimeters. So the brakes are okay. But the alternative is that they are less than 4 millimeters. We think that they're actually less than because this researcher is investigating the possibility that this company is trying to oversell the brake pads, saying that you need them when you actually do not. Okay, so they're investigating that. If they're less than 4 millimeters, then the brakes are unsafe and they need to be replaced. So, type 1 error. The brakes, if the null is really true. So the HA or the HO is true. Brakes are okay. But you get a sample that causes you to reject the null. So we reject the null and we think that they are unsafe and need to be replaced. The reality is they are okay, but we are told, or our sample makes us think, they are unsafe and need to be replaced. So what happens? Well, we might waste the money on getting brakes that are still good and do not need to be replaced. Okay, so there's a consequence. Now, type 2 error. HA is true. So up here, HA is true. So the brakes are unsafe and they need to be replaced. But we failed to reject a false null hypothesis. Type 2 error, type 2 error. So we failed to reject a false null hypothesis. Type 2 error. So the reality is HA. The brakes are unsafe and need to be replaced, but we are told they are okay. So the consequence, what happens? Well, we don't replace the bad brakes, and we could possibly have accidents because the brakes are not stopping as they need to. So then which error would you consider more serious and why? Well, I personally think it's more dangerous to be having accidents, okay, than wasting money on replacing the brakes. Okay, so you might think otherwise, but I would rather be safe than sorry. All right, next. Number 2, so this is about the blood alcohol level. So if you get stopped, pulled over by police, and he's trying to determine if the individual should be arrested for basically driving under the influence, DUI. So the P parameter is the percent blood alcohol. So the null hypothesis is that everything's okay. In fact, the null hypothesis was we write it as equals, but typically, this kind of really means less than or equal to. Okay, so your driver's blood alcohol level is 0.08% or less. Okay, but the alternative is that they get a blood sample that has it being greater than 0.08%. So that tells us the driver's is unsafe, has too high of a blood alcohol level. So type 1 error. The null is true, so the driver is actually okay. But we get a sample that makes us think they are not, that they are past the legal limit. And so the consequence is the driver gets charged with the crime and has a fine or whatever, many consequences, many consequences down the road from that. Now, type 2 error is HA is true. So that means the driver is in bad shape. The driver's blood alcohol limit is too high and the driver is unsafe and should not be driving, but we did not detect that. Type 2 error, so the police officer did not detect that the driver was unsafe. This could be really, really, really bad. The driver keeps driving, causes accidents, possibly fatal accidents for himself, herself, or somebody else. So which do you consider more serious? While I know that the first one is very bad and it's going to cause some life issues that hopefully can be remedied in some way. The type 2 having a driver out there that's unsafe and driving while intoxicated, that could be life-changing accidents. So I considered that one worse. Okay, here we go. Medicine, checking out this new medicine for infections, but we need to see, is it toxic? Does it have too many bad side effects? So the null hypothesis is it's okay until we find that it is too toxic and it's causing some problems. So if the null is really true, that's type 1 error, but we get a sample that causes us to reject that null. So the medicine's okay, but our sample makes us think it's too toxic. So we miss out on that opportunity to find the medicine that is more effective in fighting infections. So we think the medicine's bad, but it really was okay. And so we're missing out on that new medicine. All right, how about this? Type 2 error. HA is true. So the medicine really is too toxic. Okay, but our sample did not detect that. So our sample's toxicity was not detected and the FDA think it's okay. Well, you see plenty of commercials for class action lawsuits for this. So what happens? Well, the medicine's given to patients thinking it's going to help them, but it actually is toxic and it ends up causing problems later on down the line. Okay? So the doctor and patients would consider type 2 worse because they don't want to have toxicity given to the patients. And so that would be really bad. And of course, the pharmaceutical company who is in it for the money, they would consider type 1 worse because if their medicine is good, they want to be able to market it. They do not want to put a good medicine away whenever they could actually make a lot of money off of it. All right, next. Last one, I think. So here we have an engineer who says, hey, we're going to make these parts, and I think we can make them faster. Well, the problem is, and here's where it comes in, reducing the time to assemble those parts is going to take, shutting down the plant for a little bit, retooling the plant. It's very expensive to do that. It'll involve some downtime. So if this method is as good as it's claimed, then in the long run, it will save money. So you have to know what's happening with that. So if the average length of time to make the widgets is still 75 seconds, then I have over here in purple, then that means the new method is not benefiting, is not better. And therefore, if they stopped and retooled the factory, then that would be a big waste of money because they're spending a lot of money refabricating the factory when it's actually not creating a better manufacturing process. Okay. But over here, if the average time is less than 75, then yes, the new method is better. And we will be better off in the long run by switching over the factory to this new manufacturing process. All right. So type 1 error, if the null is really true. So the new method is not beneficial, okay, because it's still going to be a 75-second time to assemble the parts, okay? But our sample made us think that it was. And so what happens? This is a big, huge consequence. The company spends a lot of time retooling the factory, thinking that that process will be good. But since the company ends up wasting money, it actually doesn't improve production time. So the process doesn't help, and yet they stop the factory, totally revamp it, and waste a lot of money thinking it's going to help their process, but it really doesn't. So the company wasted a lot of money if there is a type 1 error. All right, number 2, or next, type 2 error. HA is true. So the new method is reducing the production time of the widgets, and it will increase the company's profits in the long run. But we did not detect that. We think that the new method wasn't much better, and so we do not stop and retool the factory. They miss out on an opportunity to make more money with the improved production time. All right, so the consequence, of course, of that error is more of a missed opportunity to improve their manufacturing process for profit in the long run. Now, let's talk consequences. So the engineer, the person who came up with this new manufacturing process, he would really hate for there to be a type 2 error, because if the manufacturing process is better, like he says it is, he wants to be able for it to be detected. He wants to improve the company and get credit for it, of course, okay, in the long run. But the company is going to have think that a type 1 error is the most dangerous for it to have, because that would say that they're wasting a lot of money retooling the factory on the process that has no monetary benefit. So they're shutting it down, refabricating the factory, retooling it, switching it over when it's not going to do anything. Okay, that would be worse for the factory, especially like here in the short run. So there you go. Now, the reason these are important, okay, is because there are mechanisms that we can control. We can control the size of the samples and we can control the alpha. And those are things that can be controlled so as to reduce the probability of certain errors. So that's the whole point of talking about what's worse, so that we can then decide, okay, what do we need to control? What do we as a researcher need to address so that we can minimize that type of error? All right. So I hope that that makes sense to you and that you're doing well on interpreting your errors.